Hello, my name is Veronica Patakova. In this video, we will review naproxen. Naproxen has a chemical formula of C14H14O3. The IUPAC name is 2S2,6-methoxy-naphthalene 2-ill-propanoic acid. The common name of the molecule is naproxen. It is also known by S-naproxen, nonyl, equiproxen, napron, and pronoxen. Naproxen contains a carboxylic acid, methoxy group, that's the ether group of the molecule, and naphthalene, it's a two-ring system, two benzene rings fused together. Looking at a molecule, we do see a carboxylic acid, we do see a methoxy group, and we do see a naphthalene group. It's a two benzene rings. It was interesting to learn that naphthalene and methoxy group together form methoxy-naphthalene. The molecule of naproxen has one chiral center. It's the central carbon that is connected or attached to four different substituents. The first priority group would be the carboxylic acid group. Then we would have, so the carboxylic acid would be our highest priority. The second highest priority would be the naphthalene group. And then the third priority would be the methyl group. And then the hydrogen that is not shown here, but it would be pointing towards us, sticking out of the page, would be the last fourth group. It's our hydrogen atom. There are two configurations of stereocenter. It can be an R or S configuration. Normally the way we would look at it, if the hydrogen is going into the page and our substituents can be traced clockwise, it would be an R configuration, and if they are traced counterclockwise, it will be an S configuration. In this particular example, because our hydrogen is coming out of the page, it would be the opposite. So we have our first group is carboxylic acid, then we have two fused benzene rings. The naphthalene group is the second, and then we have our methyl group, and if we trace it, it goes counterclockwise, but because our hydrogen is going out of the page, not into the page, it is R-naproxen, not an S-naproxen. When looking at isomers, as we just reviewed, naproxen has an R and S configuration of central carbon, chiral carbon. So it does exist in two enantiomeric forms. The diastereomers would form if naproxen would react with a different chiral molecule, wherefore creating a second chiral center, then it could be possible. And constitutional isomers, we do know that it would be a molecule that would share the same molecular formula with naproxen, but a different connectivity. It was interesting to learn that the active form of naproxen is S-naproxen, the S enantiomer. It is used as a non-steroidal anti-inflammatory drug. It is used to relieve pain, fever, inflammation that could be caused, or pains that could be caused by headaches, muscle aches, arthritis, menstrual periods, common cold, toothaches, and other conditions. Overall, it does have pharmaceutical use, and it helps to provide relief to many patients. We do have interesting literature and articles that were incorporated into this presentation. And thank you very much for your time.